I hope all of you are doing good. Let's start today's chapter, Factorization of Algebraic Expressions. Introduction. While in the previous chapter we have learned about multiplication of algebraic expressions, in this chapter we shall do the opposite. That is, we shall find two or more algebraic expressions equal to a given algebraic expression. So the process of writing a given expression as a product of two or more factors is called factorization. The fact is, we know that a given positive integer can be expressed as a product of prime factors. For example, 60 can be written as like this. Of each of the numbers, that is 2, 2, 3 and 5 are known as the factors of 60. Also, process is known as factorization. The same procedure applies to algebraic expressions also. If we consider a monomial, that is 7ab, then 1 into 7ab and 7 into ab, 7ab is equals to 7a into b, or 7ab is equals to 7 into a into b. Thus, if an algebraic expression is written as a product of two or more algebraic expressions, then each of these numbers or expression is called a factor of the given algebraic expression. Factorization. The process of writing a given algebraic expression as the product of two or more factors is called factorization. Factors of a monomial. The factors of a monomial consist of every literal, their product and number that will divide it exactly. Okay. For example, write down all possible factors of 8x square y. Okay. So, factors of 8 is 2 into 2 into 2 and x square, x into y. Okay. So, also all possible combinations of these factors are also factors of 8x square y. Thus, the possible factors are, these are the possible factors, right? Now, common factors and highest common factors of monomials. Factors that are common to two or more monomials are called their common factors. The common factor having the greatest coefficient and highest power of the variables is known as the greatest common factor. Example, we have to find the greatest common factor of the monomial 7x square y, 21x square y square and 42x square y 5. Okay. So, greatest factor of 7, 21 and 42, if we consider these number, is what? 7. Okay. And the greatest common literal is what? X square y. Right. Therefore, greatest common factor is, that is G, greatest common factor is what? 7x square y. Okay. From this we can derive the following. We find the GCF of given monomial, GCF greatest common factor. Number 1, find the GCF of the coefficient of given monomials. 2, find the least exponent of every common literal. 3, write the GCF as the product of steps 1 and 2. Factorization, when a common monomial factor occurs in each term. An algebraic expression can be written as a product of the greatest common monomial and the quotient obtained by dividing the given expression by this greatest common monomial. We have to factorize 8x plus 12. Let's do it. 8x plus 12 is what? Okay. So, first we will take 4 as common, 2x plus 3. Okay. Right. Similarly, 5p minus 15q. Common divisor is 5. P minus 3q. Right. Next, factorization with a binomial is common. When a binomial is common, to factorize an algebraic expression containing a binomial as a common factor, we write the expression as a product of the binomial and the quotient obtained by dividing the given expression by this binomial. For example, we have to factorize 8 3x plus y plus 7 3x plus y. So, how you gonna factorize it? See, 3x plus y is common. And 8 plus 7. 8 plus 7 is 15. 3x plus y, 15. Or write 15, 3x plus y. Right. Now, grouping. Sometimes the terms of the given algebraic expression are arranged in suitable groups such that each group has a common factor as shown in the examples that follows. Okay. See, let's factorize this. So, this is ay square plus bz square plus by square plus az square. So, what will you do? First, see, ay square, and then you will write this one, az square, means we will regroup, then by square plus bz square. Okay, we can regroup like this. Now take the common, which is a y square plus z square plus b y square plus z square. Okay, so we'll write y square plus z square and a plus b, right? Next, perfect squares. When an expression is a complete square, we use the following. Okay, about this we learned in the previous chapter also. Okay, these you will use these identities. Okay, for example, 9x square plus 24xy plus 16y square. Okay, 9 is a square of what? 3x square. Okay, then plus, and 16 is the square of what? 4y square, plus 2 into a is what? 3x, and this is 4y. Okay, now this has become the identity, that is a plus b square, right? So you will write what is a? 3x plus 4y square. Okay, cases of difference of two squares. In such cases we use this identity. Okay, so let's do it. Identity is what? A square minus b square is equals to a plus b, a minus b, about which we studied in the previous chapter. Okay, 3x square minus 81 square y square, 36 is square of 6, 6x square minus 81 is the square of 9, 9y square. Now use this expression, 6x plus 9y and 6x minus 9y, right? Exercise 15.1. Find the highest common factors of the following. Okay, we have 8xy square and 40xy. Okay, if we find the 8 and 40, so highest numerical factor is what? 8 and here xy. So 8xy, that is HCF. HCF is 8xy, right? Things to remember. When an expression is a product of two or more expressions, then each of them is called a factor of the given expression. 2. The process of writing an expression as the product of two or more factors is known as factorization. 3. The greatest common factor of two or more monomials is the product of the greatest common factors of the numerical coefficients and the common literals with the smallest powers. 4. When a common monomial factor occurs in each term of an algebraic expression, it can be expressed as a product of the greatest common factor of its terms and the quotient of the given expression by the greatest common factor. 5. When a binomial is a common factor, we write the given expression as the product of this binomial and the quotient of this given expression by this binomial. If the given expression is a complete square, we use one of the following formulae. Okay, and if the given expression is a difference of two squares, then to factorize, we use this formula. Right, students? Okay, I hope you have understood this chapter. Now you will do practice of the remaining questions.